The Fluke 1730 energy logger has the advantage that the power supply can actually be separated from the instrument to fit in tight locations where depth of the instrument is actually preventing it from being locked in the cabinet. So to reduce the depth, we simply remove the power supply by turning the unit over and sliding up on the catch and lifting it off. Once we have it off, we can see the DC input to the power supply that goes to the instrument. With it separated, we are going to make use of the included DC cable to then make that connection to the instrument. So one end goes to the power supply, and the other end of the DC cable connects to the top of the instrument. So now we have the connection between the power supply and the instrument. The second part is, how do we get power to the power supply from what we're measuring? For that, we connect up the voltage leads as normal. So looking at the connections that are labeled A, B, and C, we make the voltage lead connections to the instrument. So now I have my measurement leads, phase A, B, C, and neutral, to the instrument. And then to go from the measurement leads to the power supply, we have two choices. We have a set of short cables that will allow us to connect between the two pieces right next to each other. But in a lot of locations, we actually need to locate them in a separate part of the cabinet. So we have much longer leads that then we can use to connect from the measurement leads. So for a three-phase Y or single phase, typically you would go from phase A to neutral. If you're on a three-phase delta that's under 500 volts, simply take the black wire and connect it to phase C. On the power supply, we would then connect the red wire to the left connection and the black wire to the right connection. Now we have power from what we're measuring to the power supply, and then the DC out then goes to the instrument. We then can lay these in separate parts of the cabinet and still get our measurement done.